with these log properties, it's nice just to convince ourselves that they actually work. So let's convince ourselves, okay? So, for example, the first property, it said that the log of something times something is the log of that something plus the log of the second something. Let's just see if that works. Let's do a couple of examples. For example, if I have the log of, let's say log base 2 of, let's pick some nice numbers, like 2 times 8. That should equal the log base 2 of 2 plus the log base 2 of 8, right? Just following this log property. Well, let's see if that really works. Let's see. This is the log base 2 of 16. Now, remember, logs are just exponents, so this is saying 2 raised to what exponent is 16? Let's see, 2 times 2 times 2 times 2 is 16, so this is equal to 4. All right, let's see if that equals this side. Log base 2 of 2. 2 raised to what is 2? Oh, 2 raised to the 1 power is 2. 2 raised to what is 8? 2 raised to the 3rd power is 8. Hey, look, it works. Isn't that fabulous? And it will always work with these properties. Let's do a couple others. How about the property the log of something divided by something is the same as the log of the numerator minus the log of the denominator. Let's do a common log, shall we? So let's say the log of 10,000 divided by 100. All right, well, this says that that should be the same as the log of 10,000 minus the log of 100. Let's see if that works. So let's see, if I'm doing this side, the log of 10,000 divided by 100, let's divide everything by 100. That's the log of 100. Remember, this is the common log. There's a little invisible 10 there. 10 raised to what power is 100? Oh, 10 squared is 100. So this equals 2. Let's see if that equals this side. The log of 10,000, 10 raised to the 1, 2, 3, 4. 10 raised to the 4th equals 10,000. So this piece equals 4. Let's see, 10 squared equals 100, so log of 100 is 2. 4 minus 2, last time I checked, was 2. 2 equals 2. Isn't that amazing how this works? Now, all these properties work for any base. I just did an example here with the base of 10. The previous example was the base of 2. All these properties also work for natural logs, which of course has a base of e. Remember that? Right? I could say log base e of something, but we just call that natural log. It has its own symbol. So let's demonstrate the power property, right? In other words, the log of something raised to something is equal to that exponent times the log of a. Let's do an example of that with logarithms, with natural logarithms. So let's say the natural log of e to the 5th, right? Well, that should equal, according to this rule, 5 times the natural log of e. All right, well, let's see. What does this side equal? Well, we know there's a little invisible base of e there. E raised to what equals e to the 5th? Oh, well, e to the 5th equals e to the 5th, so that equals 5. 5 times the natural log of e. E raised to what exponent equals e? Oh, well, e raised to the 1 power equals itself. Oh, look at that. That one works too. Isn't that fabulous? I just love math. It all works out. So this is just demonstrating that those properties do, in fact, work. So let's see some of these these log properties in action. If I had a situation like this where I said, let's expand this expression. By expand, I mean spread it out, write it in terms of many logs. Now, this is a little unclear, this direction. Often you'll have some multiple choice options to choose from. But I just want you to get a sense of how this works. So right now this is expressed as one log. I want to express it using many logs. So let's unpack this. I've got an exponent. I've got some multiplication. Ooh, I have a square root. I think I can write that as an exponent, can't I? Wouldn't that be the same as a squared times b to the 1/2, all divided by c? All right, let's start there. So I now had some exponents, I had some multiplication, some division. Let's just see how far we get. So let's deal with that multiplication first. A squared times b to the 1/2. Well, I can think of that as the log of a squared plus the log of b raised to the 1/2. Division, that becomes subtraction of the log of c. All right, I've expanded that out. Now I can deal with those exponents. Remember, when you're raising an exponent to an exponent, you multiply those exponents together. We typically write the 2 in front, just so everything is clear. 2 times the log of a plus 1/2 times the log of b minus the log of c. That is an equivalent statement to this guy right here. I've just expanded it out. Does that make sense? All right. Of course, I could go backwards. I could start with something expanded and ask you to condense it. Let's try one of those. Okay, let's try this one right here. So now we're going the other direction. I want to write this as one logarithm. Okay? So I'm going to use the properties of logs now to condense this. All right, so I want one big log base 2. Okay? So here we go. This little guy right here would become an exponent. That's going to be x to the 5th. My subtraction is going to set me up to divide, so I'm going to put the x to the 5th up here and be ready to be dividing. Okay, it looks like I've got these parentheses. That means I'm dividing this whole expression. So this whole shebang is going to go down here. This little guy is an exponent, so that's 3 to the 1/2, also known as the square root of 3. Addition becomes multiplication. That little guy is an exponent to the a to the 7th. There it is. It's condensed. Or if you like those radicals, you could write this as x to the 5th over the square root of 3 times a to the 7th. Okay? We have condensed that log. All right? Now, a third thing that we might do, which is a little fun, I think, it's kind of like a little puzzle. Sometimes you'll be asked to expand an expression. For example, express the log of 12 in terms of a and b, given that a equals the log of 2 and b equals the log of 3. Okay, so let's say you have a situation like this. Express the log of 12 in terms of a and b, given a is defined to equal log of 2 and b is defined to equal the log of 3. Interesting. Well, you know, I want to start by looking at those ingredients. I want to rewrite 12 in terms of 2 and 3. Can I rewrite my expression log of 12 using 2's and 3's? I think I probably can. Can I think of that as the log of 2 times 2 times 3? 2 times 2 is 4, 4 times 3 is 12. Or I could write that as 2 squared times 3. So far so good. Do you see where I'm headed with this? Now I'm going to use that property that says when you are multiplying things, that's the same as adding their logs. So that's the same as the log of 2 plus the log of 2 plus the log of 2. Aha! Okay, but I want to write this in terms of A and B. So now I go down to my little key. Okay, A is the same as the log of 2. Oh, so the log of 2 I can replace with the A. Plus log of 2, there's another A. Log of, oh, what the heck? This should have been a 3. My apologies. Just making sure you're sharp. So that's the log of 3, of course. Log of 2 plus log of 2 plus log of 3. Log of 3 now is going to be my B. Can I simplify that a little bit? Sure. A plus A is also known as 2A plus B. All right, so this is just kind of a fun little exercise that allows us to practice our properties of logs. I hope you find these as fun as I do.